In this session, we'll provide an overview of what's new in the VMware Validated Design for Software-Defined Data Center 4.0 that GA'd on the 2nd of March, 2017. This session addresses all the major changes to the design from the prior 3.x releases. And my name is Ryan Johnson. I'm a staff technical marketing architect in the Integrated Systems Business Unit at VMware, where I focus on the software-defined data center. If you have any questions about this presentation or the VMware Validated Designs, please feel free to reach out to me at 10:30 a.m. on Twitter or my email, johnsonryan@vmware.com. In terms of the agenda, we'll discuss the software bill of materials in the design, insight into key design updates, their justification, and any implications. In addition, we'll share some key resources to get started with a new release. And first up, let's jump into the software bill of materials in 4.0. The 4.0 release has marked a substantial wave of updates to the bill of materials for the software-defined data center implemented and operated following the VMware Validated Designs. Most notable, you'll see that we've included a wave of 6.5 updates and supported adjacencies. These include vSphere 6.5, the most recent update to our flagship product and components like vCenter Server, ESXi, and vSphere Replication. vSAN 6.5, our industry-leading software-defined storage solution built into vSphere. NSX 6.3, Network and Security Virtualization, a fundamental element of the design that provides Layer 2 through Layer 7 network and security services in software. Site Recovery Manager 6.5 provides disaster recovery for the management stack and business workloads when implementing a dual-region design. vRealize Automation 7.2, the cloud management platform for the service catalog, self-service portal, blueprint creation, governance, and third-party workflow integrations. vRealize Business for Cloud 7.2 is an integrated cost analysis and financial reporting for your private cloud. vRealize Operations 6.4 and integrated management packs to report, manage, and forecast the health, risk, efficiency, and capacity across your SDDC. And lastly, vRealize Log Insight 4.0 and integrated content packs to aggregate and analyze logs across the SDDC. For a detailed list of the individual products, management packs, and content pack versions included in this release, please refer to the design documentation at vmware.com/go/vvd-SDDC or check out the release notes. Well, there's been considerable update to the documentation in terms of accessibility for this release. In prior releases, we only had the documentation available in PDF format, but in 4.0 release, we're now making all the documentation readily accessible online as we do for all our products. Now, this is a great way for you to read, search, browse, bookmark content across all VMware Validated Design documentation. And in addition, the PDF documentation will also still be available and is available directly from the online docs or by visiting vmware.com/go/vvd-SDDC. Now let's dive into the major design changes included in this release. And we'll follow the flow seen in the design documentation and touch on the changes seen through the physical layer, the virtualization layer, the cloud management platform layer, and the cloud operations layer. First up, the physical layer and a touch into the virtualization layer. In this release, we've raised the minimum memory per nodes in the management cluster to 192 gigs each from the prior 128. This allows us to account for some added growth and recalculations for the minimum resources for the entire SDDC management stack, which requires a total of 424 gigs in a dual region deployment model. You'll see a little later that portions of this are to account for items like the increase in memory for vRealize Business for Cloud or vRealize Orchestrator and other management components. Now, most deployments of the management cluster will either use an SD card or SATA DOM for the boot device so that all local disks can participate in a distributed vSAN data store for either capacity or the caching tier. SDs are super simple and inexpensive option to configure and manage. However, in order to accommodate a local scratch partition for ESXi on the card, we've raised our guidance from a minimum of an 8 gig SD card up to a mere 16 gig card. And based on feedback from our customers, partners, and our field, in this release, we've introduced the use of a load balancer to increase the availability of the platform services controllers used in the SDDC stack. This is accomplished by establishing an NSX Edge Services Gateway in front of the platform services controllers. In terms of the implementation, the two platform services controllers are deployed in each region where their certificates are updated under a common FQDN for their region. This FQDN is then later used by the NSX Services Gateway that will act as our load balancer. So in each region, the first platform service controller will be set to respond to a designated DNS record, and the management vCenter server instance, once deployed, will be pointed to this record in its region. Once deployed and configured, NSX is then staged, and an NSX Edge Services Gateway is deployed to provide load balancing services to the PSCs, along with the required profiles and virtual servers on the edge. Following this edge configuration, a simple change is made to the DNS record from the first PSC now to the load balancer VIP. Additional compute vCenter instances are established directly with the VIP's corresponding DNS record. And in the event of an issue with the load balancer later on, the DNS record can be swung back for troubleshooting or maintenance. Recall that in this release of the VMware Valley design for SDDC, we've updated to vSphere 6.5. vSphere 6.5 has introduced several improvements, one of which is vSphere HA admission control. Starting with vSphere 6.5, this configuration just got simpler. The first change is that the administrator simply needs to define the number of hosts that the number of host failure in a cluster can tolerate, FTT, or failures to tolerate if you think of it in terms of vSAN, for example. Once the number of hosts is configured, vSphere HA will automatically calculate a percentage of resources to set aside and apply a percentage of cluster resources admission control policy. As hosts are added or removed from this cluster, the percentage will automatically be recalculated. Additionally, the vSphere web client can issue a warning if it detects that an HA event would cause a reduction of VM performance and allow the administrator to configure how much of the performance loss is tolerable. We've designed the initial 4-node management cluster's admission control policy to tolerate a single host failure with a percentage-based failover capacity. By using the cluster resource percentage, it works well in situations where virtual machines have varying and sometimes significant CPU and memory reservations. As mentioned previously, vSphere 6.5 will automatically calculate the reserved percentage based on the host failures to tolerate and the number of hosts in the cluster. In the 4-node management cluster, vSphere sets the reserved failover to 25%, and therefore, only the resources of 3 hosts are available for use. In the 3.x design, we simplified the pod design down to a 2-pod architecture based on customer and partner feedback. 1 pod for management, and then 1 for the initial edge and compute. Customers can add additional compute pods as needed as they expand their SDDC. In this initial shared and edge compute pod, we established a resource pool for the required SDDC NSX controllers and NSX Edge Services gateways with a CPU and memory reservation. The NSX components control all network traffic in and out of the SDC, as well as update route information for inter-SDDC communication. In a contention situation, it's imperative that these virtual machines receive all resources required. And in this release, we've raised our guidance for a memory reservation to 16 gigs from 15 gigs with a normal share level, and we have retained the CPU share level at high. Keep in mind that during a contention scenario, the SDDC NSX components for the edge services in the cluster will receive more resources than all other workloads. And as such, monitoring and capacity management must continue to be a proactive activity for your SDDC. In this diagram, you can visualize the deployment topology for the management pod and the shared edge and compute pod, seen here on the rack on the left. Recall that these pods and their clusters will always be bound to the rack. Now, to the right, you will see additional compute pods that can be added to expand the resources for the SDDC. This is where a customer's applications will run. And these are always designed by the customer, partner, or professional services to meet the requirements of those business workloads. In prior releases, all clusters were bound to the compute pod and the rack. Think of this as binding the clusters vertically within the racks. In this release for 4.0, we've lifted this restriction that binds compute clusters to a pod and subsequently a single rack. Now compute clusters may span racks horizontally over the layer 3 connection if so desired. By default, vSphere 6.5 uses TLS SSL certificates that are signed by the VMCA. These certificates are not trusted by end-user devices or browsers. It's a security best practice to replace, at a minimum, user-facing certificates with certificates that are signed by a third party or enterprise certificate authority. And this is also known as the VMCA in hybrid mode. Certificates for machine-to-machine communication may remain as VMCA signed certificates. In 4.0, we now use SHA-2 or higher algorithm when signing certificates instead of the SHA-1 algorithm, which is considered less secure and has been depreciated. A quick reminder that the VMware Valid Design for SDDC comes with the SSL certificate generator CertGen VBD. You can use this tool to generate your certificate signing requests and certificates through a Microsoft CA or another provider. Using the CertGen VBD tool saves you tons of time when creating signed certificates. Refer to the knowledge base article 214-6215 for more information. But if the CertGen VBD tool is not an option for your environment, we understand that, and the design also includes a validated procedure to create and replace the certificates, all while using the SHA-2 based certificates. This release also includes the addition of the vMotion TCP/IP stack to isolate vMotion traffic and to assign a dedicated default gateway for that traffic. This update was added directly based on community feedback. By using this new stack, the design routes traffic for the migration of virtual machines that are powered on or powered off by using a default gateway that is different from the gateway assigned to the default stack on the host. It assigns a separate set of buffers and sockets. It avoids routing table conflicts that might otherwise appear when many features are used in a common TCP/IP stack, and it isolates traffic to improve security. vSphere 6.5 now allows an administrator to create VM to VM dependency chains. These dependency rules are also enforced if and when a vSphere HA is used to restart VMs from failed hosts. This is great for multi-tier applications that do not recover well unless they are restarted in a particular order. A common example would be a 3-tier application such as a database, an app, and a web server. The validation checks are also automatically done when the feature is configured to ensure circular dependencies or conflicting rules are not unknowingly created. The VM to VM rules must also be created that complies with the restart policy level. In this example, if the app server depended on the database server would need to be configured with a higher priority level or equal to that of the app server. So let's illustrate that new feature in a 3-node cluster example here. And in this cluster, we have 3 applications that span across several VMs. The first is represented with the color blue, the second with the lighter blue, and finally we have a third that is labeled in green here. We can create a couple of dependency rules for these solutions. For the blue application, VM1 should start first, followed by VM2, 3, and 4. For the light blue application, VM5 should start first, followed by VM6, 7, and 8. And there are no dependency maps for VM9. If the first host were to fail, this is how the applications would restart. VM1 and VM8 would restart at the same time. That's because there's no dependency map between VM1 and VM8. Once VM1 has completed the restart process, VM2 will then restart. Here in the VMware Valid Design for SDDC 4.0, we can translate this construct and use it to only protect the solutions that are established for the SDDC. For example, vRealize automation, but we can also use it to control the startup order of the different layers. So here you can see that in the VVD, it establishes virtual machine groups of layers or for components in the solution. Here I've highlighted the vRealize automation virtual appliances group, where I've defined these 2 virtual machines. And not seen here are also anti-affinity rules that ensure that these appliances are always running on separate hosts in the cluster. Once the groups have been defined, we create the virtual machine rules to set the startup order of the virtual machine groups. This ensures the correct startup order of the SDDC management components. And here in this example that's highlighted, I've set a rule for the SDDC Cloud Management Platform 03. This is my 3rd startup rule in the set. And it defines that vRealize Automation Virtual Appliances group members should start prior to the vRealize Automation IaaS Web Server group members. And notice that there are 8 startup rules in the SDDC Cloud Management Platform example to orchestrate the startup of all the layers. These groups are also applied across the entire management cluster for all its pieces and parts. To simplify the configuration of hosts, we are now using the construct of host profiles in the design. But we're doing this in the management cluster. Now, although this design decision is specifically for the management cluster, we do encourage the use of host profiles across the shared edge and compute, as well as any other additional compute clusters you may add into your SDDC. But also keep in mind that anytime an authorized change is made to a host, the host profile must be updated to reflect the change, or the status will be reported as non-compliant during the next compliance check. Over on the networking side of the design, we've made some minor changes to the vSphere Distributed Switch, or VDS, configured across all the pods. We've provided guidance to enable vSphere Distributed Switch health check on all distributed switches, those used for the management pod, the shared edge and compute pod, and additional compute-only pods. The use of the health check ensures that all VLANs are trunked to the host attached to the VDS, and will also ensure that the MTU sizes match the physical network. And in addition, in addition to enabling the health check, we've also updated each vSphere distributed switch to use version 6.5.0 provided through vSphere 6.5. And this ensures that all new capabilities of the switch are made available to all the clusters. In prior versions of the design, we created a universal transport zone that encompassed all shared edge and compute pods from all regions for workloads that required mobility between regions. While this worked great, we discovered that vRealize Automation cloud management platform was not able to deploy on-demand universal network objects against the secondary NSX manager in region B. To alleviate this issue in 4.0, we've introduced a second transport zone. We've added a global transport zone in each region that encompasses all shared edge and compute clusters for use with vRealize Automation on-demand network provisioning. The addition of this transport zone allows all regions to deploy on-demand network objects, but the only implication is it now requires that the shared edge and compute pods have these two transport zones established. In addition to the second transport zone that benefits the on-demand networks objects across the regions, we've also added a standard distributed logical router, or DLR, for the shared edge and compute clusters in each region. This distributed logical router provides east-west routing for workloads that require these on-demand network objects delivered through vRealize Automation and NSX. It also reduces the hop count between the nodes attached to it to 1, thereby reducing our latency and improving performance. Now, if the DLR reaches the limit of 1,000 logical interfaces, which is a lot, a subsequent DLR would be deployed alongside it. In this design, both the UDLR, Universal Distributed Logic Router, and the DLR control VMs are deployed in high availability, and of course, have their anti-affinity rules also generated for vSphere HA. However, in the event of a control VM failover, for example during a host outage and the control VM begins its restart, the router adjacency from the upstream devices such as the TORs to subnets behind the UDLR or DLR are lost for a brief period while the second control VM in the pair takes over. Now, to address this gap in time and the resulting loss of adjacency, we've added in the design decisions the ability to create one or more static routes on the ECMP-enabled NSX edges for the subnets behind the UDLR and the DLR. These static routes have a higher admin cost than those that are dynamically learned, and as a result, network connectivity is not impacted during the control VM failover scenario. In terms of implications, this does require that each ECMP NSX edge device is configured with static routes to the UDLR or DLR, and if any new subnets are added behind the UDLR or DLR, that those routes must be updated on the ECMP edges. This could easily be scripted using the power of Power NSX. While not so much of a new feature in 4.0 design, it's certainly worth mentioning that the VMware Valley design for SDDC uniquely establishes micro-segmentation for the solutions in the design, but also for users and administrators of those solutions. This is provided by harnessing the power of NSX's distributed firewall policies, or DFW. By defining explicit rules for the distributed firewall, we can designate access to and access between management applications. Now, this is achieved through a four-step process where first we add the vCenter server instances to the NSX distributed firewall exclusion list. We then create NSX IP sets for all components of the management cluster, and then we create NSX security groups. From those pieces, we can now create distributed firewall policies using the IP sets and security groups. So for example, in this screenshot, we can see that we have rules allowing specific services to administrators, such as the VAMI and SSH access to VMware virtual appliances in the stack, among many other predefined rules in the design. We've also provided guidance for data store usage, both on vSAN and non-vSAN backed storage. A vSAN is the primary storage for the management cluster. By design, when a vSAN data store reaches 80% usage, vSAN will initialize a rebalance task, and this task can be very resource-intensive operation across the cluster. And as such, we recommend ensuring a buffer of at least 30% is always maintained to avoid this operation. Now, if you foresee that you need additional growth for your vSAN data store because it's growing and is being utilized, this can easily be extended with the addition of more disk for the vSAN capacity tier. If a non-vSAN data store is used for the initial shared edge and compute cluster, do ensure that at least 20% of free space is always available. If the data store runs out of free space, services that include NSX Edge Services gateways for north-south routing and NSX controllers may fail. And to prevent this, maintain at least 20% of free space. This can be proactively managed and achieved using the monitoring and capacity management components built into the design. For other compute clusters that are non-vSAN backed, it's always recommended to retain at least 20% threshold on this data store for snapshots and swap if required. Now, speaking of virtual machine swap files, on vSAN-backed clusters, such as the management cluster, we provided guidance to configure the VM swap as sparse objects. By enabling this setting on each host in the cluster, it creates virtual swap files as sparse objects on the distributed vSAN data store. The sparse virtual swap files will only consume the capacity on the vSAN as they are accessed, which significantly reduces the space consumed on vSAN if the VMs do not experience any memory overcommitment. Any overcommitment may require the use of virtual swap file and need to consume storage on the vSAN data store. To enable this capacity, an advanced setting on all ESX hosts in the vSAN cluster must be set. In the vSphere web client, go to the hosting clusters, select the host, select configure, then the advanced settings and edit. You can enter search criteria for vSAN and find the swap thick provision disabled setting and set it to a value of 1. Alternatively, if you like, you can go into the console for each host and set this manually using the ESX CFG-advanced configuration. Again, setting the swap thick provision disabled to a value of 1. Now, to illustrate this, we can look at an example capacity before the vSAN swap thick provision disabled is set to a value of 1. And here we can see the swap is using 84 gigs of the vSAN data store. But after setting the value to 1 and restarting the VMs, the usage drops to a mere 88 megs. This is from 84 gigs down to 88 megs as an example. And this is a significant reduction in storage consumption on the shared vSAN data store. Now let's turn our attention to the cloud management platform that consists of vRealize Automation, vRealize Orchestrator, and vRealize Business for Cloud. In this release, we've depreciated the prescriptive configuration for vRealize Automation seen in the Rainpole examples of prior releases. Instead, we're providing guidance through the IT Automating IT use case documentation, which is now seen online, and then download as PDF. This documentation includes implementation steps for a set of scenarios, the procedures and commonly used executed tasks, and it also includes new chapters on integrating vRealize Automation with Infoblox IPAM, creating multi-tier application patterns, and using NSX microsegmentation for those multi-tier applications. If you recall from previous releases, the SDDC management applications run in conjunction with NSX and leverage the capabilities of distributed logical routing, distributed firewalling, and load balancing. As an example, here we can see the traffic flow between users on the physical network and the NSX ESGs to the distributed logical router, to this logical network, to the NSX ESG for load balancing, and then to the vRealize Automation appliances to access the Cloud Management Portal UI. We've made some modifications to align the design with the latest practices, which now include changing the load balance algorithm from IP hash to round robin for all pools, and updating the application's profiles to maintain session persistence for vRealize Automation appliances and vRealize Automation IaaS web servers. We also set an expiration date of 1800 seconds for those sessions. Session persistence is not configured on the vRealize IaaS Manager and vRealize Orchestrator appliance profiles. In the design, we're also using default vRealize Business for Cloud appliance size. However, the default memory size for the appliance has increased to 8 gigs from 4 gigs between versions 7.1 and 7.2. This default appliance size will accommodate up to 10,000 virtual machines, which is in the design objective. For vRealize Business for Cloud remote collectors, these will use reduced memory footprint of 2 gigs, as these do not run the server service and can operate on this reduced footprint. Do recall that the design also uses 2 external vRealize Orchestrator appliance instances. It does not use those embedded in vRealize Automation appliances to ensure isolation between the vRealize portal components and customer workflows. The design accounts for a recent increase in the resources required for these appliances, up to 6 gigs of memory and 17 gigs of hard disk. The vCPU remains at 2 vCPU. As you may recall, vRealize Operations tracks and analyzes operations of multiple data sources within the software-defined data center by using specialized algorithms and analytics. These algorithms help vRealize Operations Manager to learn and predict behavior of every object it monitors, and users access this information by using views, reports, and dashboards. Now, in this release, we've actually changed some of the guidance from using a 4-node medium-sized vRealize Operations Analytics cluster down to a 3-node minimum vRealize Operations Management cluster. Right? Now, this is a starting configuration, and if the SDDC expands past 1,000 virtual machines to start, additional data nodes can be added to the analytics cluster. However, the number of nodes should not exceed the number of ESX hosts in the management pod -1. For example, in the management pod, if the management pod contains 6 ESXi hosts, you could deploy a maximum of 5 vRealize Operations Manager nodes in the analytics cluster, and this would support up to 5,000 virtual machines in the design. With regards to capacity, the ESX host must be large enough to accommodate a VM that requires 32 gigs of RAM without bridging NUMA node boundaries, and the management pod must have enough ESXi hosts so that the vRealize Operations Manager can run without violating the vSphere DRS anti-affinity rules. vSphere 6.5 introduced a new powerful model for Update Manager, and in turn, we've now added vSphere Update Manager to design and day 2 operations. The VCSA now includes vSphere Update Manager out of the box, and all the features you know are much easier to manage and benefit from all the new enhancements for the VCSA and performance and resiliency. And some of these include that vCenter and VUM are now run on Photon OS, VMware's own Linux distribution. vSphere Update Manager is integrated and enabled by default. There's zero install. It has an embedded database. It's scalable and has low impact on the resources for the appliance. It can leverage the appliance backup model, and yes, there is no need for that Windows license. We've added a number of design decisions for operating vSphere Update Manager, but for this session, I really want to call your attention to the deployment model for the VCSAs and VUM. We've provided guidance to run the vSphere Update Manager download service on a Ubuntu Linux VM that's connected to the region-specific application virtual network. The vCenter server instances don't or shouldn't have access to the outside world, and the UMDS provides local storage and access to vSphere Update Manager repository data. It avoids cross-region bandwidth usage for repository access and provides a consistent deployment model for management applications. There will be a single UMDS in each region, and they will each use the default patch repositories provided by VMware to simplify the configuration. There's no requirement for additional resources. We've also added a small number of changes in the design for vRealize Log Insight to provide increased resiliency and better deployment and operations. We now apply vSphere DRS anti-affinity rules to the vRealize Log Insight cluster components. This prevents vRealize Log Insight nodes from being on the same host and thereby risking the cluster's high availability capacity. We've enabled launching context with vRealize Operations Manager to provide the ability to access vRealize Log Insight for context-based monitoring of objects in vRealize Operations Manager. We now configure the VCSAs and Platform Service Controller appliances as syslog sources to send log data directly to vRealize Log Insight, and this simplifies the design implementation for log sources that are syslog capable. We now configure vRealize Log Insight to ingest events, tasks, and alarms from the management and compute vCenter server instances to ensure that all tasks and events and alarms are generated across all instances in the region are now captured and analyzed for the administrator. We now explicitly configure vRealize Log Insight not to automatically update all deployed agents. For this design, it says tested bill of materials. So now manually install updated versions of Log Insight agents for each of the specified components within the SDDC for very precise management and maintenance. We configure log forwarding to use SSL to ensure that log forwarding operations from one region to the other are secure. And lastly, we configure a disk cache for event forwarding to 2 gigs. This cache provides log forwarding between regions and ensures that it has approximately 2 hours buffer if a cross-region connectivity outage occurs. The cache is calculated based on 150 megs per day of syslog source with 105 syslog sources, but may need to be increased based on your environment and your deployment model. So with backup and recovery, we've also made some changes here. We've modified our guidance, build this out. We've modified our guidance in the design to specify that we can use any vSphere API for data protection or VADP compatible solution for backups. For example, VDP, Avamar, Commvault, Veeam, and many more. Right? The design decision protects you against data loss, hardware failure, accidental deletion, or other disaster in each region. Provides you a consistent image level backups for the SDDC management stack and allows you to adapt and apply the design decisions to your own selected backup solution. Again, such as VDP or Avamar, Commvault, Veeam, and many, many more. Note that we do use VADP as an example method in the documentation, but you may use any VADP-based solution that is compatible with vSphere 6.5. In addition, some of these VADP solutions will allow you to replicate backup content, and we've added guidance to do so between regions since a cross-region replication of backups enables disaster recovery in the event of an unsuccessful cross-region failover. If used, the design retains a cross-region replicated backup for a minimum of 1 day. Also in the VVD for SDDC 4.0, we've also driven the design to use the adoption of service counts for secure application-to-application communication. Each service count has a least amount of privilege to the SDDC component for which it must communicate. In the event of a compromised account, the accessibility to the destination application remains restricted, and it also provides accountability in tracking request-response interactions between components within the SDDC. A list of all service accounts and their source, destination, component, and required roles are listed in the planning and preparation section of the documentation under external services and Active Directory users and groups. In addition, we've added a slick visual to help you visually understand the service count interactions between the SDDC components. Now to get started with this new release, you can access the documentation anytime through vmware.com/go/VVD. Here you can review all the materials that are provided in the design, from the architecture, the planning and preparation, deployment steps, validation and operations, and all available for free. Use this material and you can deploy and operate a VVD first SDDC yourself. Or you can also engage with our VMware Professional Services to accelerate your deployment on the VVD through the services engagement. And lastly, we encourage you to join the VMware Valley Designs community at vmware.com/go/VVD community. And here you can get access to new content like posters, videos, and even early access material. In addition, you can directly engage with our product managers, our engineers, our tech marketing team to directly provide your feedback and your experiences. And additional resources have been made available to you by tech marketing, product marketing, and engineering. Again, product pages, the downloads, posters, the community, videos and demos, certified partner architectures, and of course, please do follow us on Twitter at VMwareSDDC. Thank you for attending this session on what's new in the VMware Valley Design for Software-Defined Data Center 4.0. We do encourage feedback. If you have any feedback directly on this session, please feel free to reach out to me on Twitter at 1030am or by emailing me at johnsonryan@vmware.com. Thank you.